So today's topic is synchronous speed. So what is synchronous speed? It is the speed of the magnetic field that rotates around the stator of a motor. I have the symbol here, which is the N, which is a universal symbol for speed, and then sync is a shortened version of synchronous. Put them together, and you have a symbol for synchronous speed. I have the formula over here. We're going to come back to that later in this video. As you can see, I have two stators here, one labeled 2-pole, the other is a 4-pole. And then over here, I have my three-phase power represented by the 3 sine waves. All right, let's get started. Let's look at one full cycle of these sine waves. So I chose to start at the peak of the A phase, and in a previous video, that gave this a north pole. So what we're going to do is we're going to follow this north pole around the motor. So this is north here. As we move over, what ends up happening is the secondary C pole becomes north, because the main one is south. And then the B pole becomes north, and then the secondary A becomes north, and then C is north, and then B secondary is north, and then it comes back around to A is the north pole again. So one cycle here will give us one revolution of the stator in a 2-pole motor. So what is one cycle? So the electrical cycles depend on frequency. And in North America here, the frequency is 60 hertz, which is another name for 60 cycles per second. So let's go back to the stator again. If one cycle gave us one revolution, then 60 cycles per second, does it make sense? We're going to have 60 revolutions in a second here. Now, when we're talking speed, it's measured in RPM, so we have to do some kind of conversion. So let's look at that. We have 60 cycles per second times how many seconds in a minute? 60 seconds per minute. Do some simple canceling here. So we basically got 60 times 60, 3,600. And then the unit is cycles per minute. We can convert that to revolutions per minute. So in North America, the synchronous speed, or the speed of the magnetic field of the stator, for a 2-pole motor is 3,600 RPM. Now when we go to a full pole motor, a 4-pole motor, what we're looking at is, if you notice the 2-pole motor, we've been working on this quite a bit, it has 6 windings. Well, those 6 windings are half of the motor, and then we add another 6 windings to give us 4 poles. So when we're looking at speed, if we start at the A and we go one full cycle, it's only going to go to this A. So it's going to actually take 2 cycles to do a full revolution. So a couple ways we can look at this. If this is one full revolution, or one cycle gives us one full revolution, this one cycle gives us only half a revolution. Does it make sense that this is going to spin half the speed as this? So what we can do is take this number and cut it in half, and the 4-pole will give us 1,800 RPM. Now let's bring in this formula. So what the formula does for us is it already has built in the conversion and the poles into the formula. So that's where the 120 comes in. So let's just do the formula applying to this 2-pole motor. So we got 120, the frequency here, 60 hertz, divided by 2. You do the math on that, and you will get 3,600, and that's RPM. Over here, we have 120 again, times by the 60 hertz. This time we divide by 4, and that will give us our 1,800 RPM. Now, if we were to bring these same motors over to, let's say, Europe, where they have a 50 hertz frequency, then all we do is change the 60 to 50. So then a 2-pole motor works out to be 3,000 RPM, and then the 4-pole motor works out to be 1,500 RPM. You don't have to memorize this. You just have to memorize the formula and then put in the numbers as you need. And there's more than just 2 and 4 pole motors. We have 6 and 8 and 12 pole motors. But all the math and all the formulas stay the same. See you next time.